So welcome to all for the course of refrigeration and air conditioning. Now we are going to learn about we are going to solve one numerical. So based on the properties of moist air. I am reading the problem statement now. The reading from the sling psychrometer are as follows. So tribal temperature is given 30 degrees Celsius, variable temperature of moisture 20 degrees Celsius, and barometric pressure is given 740 mm of Hg. So using steam table determine number 1 dew point temperature, number 2 relative humidity, then specific humidity, degree of saturation, vapor density and enthalpy of mixture per kg of dry air. So first of all, let we calculate partial pressure of water vapor. So before that, to calculate partial pressure of water vapor, I write first of all the saturation pressure Pw corresponding to variable temperature 20 degrees Celsius. So from steam table at 20 degrees Celsius, pressure is 0.02337 bar. So Pw is a saturation pressure corresponding to variable temperature of 20 degrees Celsius. Then barometric pressure is given in the numerical, which is equal to 740 mm of Hg. So I convert this pressure into Newton per meter square. So 1 mm of Hg equal to 133.3 Newton per meter square. So 740 into this 133.3, I get 98,642 Newton per meter square. I converted this pressure in bar. So barometric pressure equal to 0.98642 bar. Then using Carrier equation, I find out partial pressure of water vapor PV equal to PW minus PB minus PW into TD minus TW upon 1544 minus 1.44 into TW. So putting the values, I have got partial pressure of water vapor equal to 0.01701 into 1.01701 bar. Now the dew point temperature is nothing but the saturation temperature corresponding to partial pressure of water vapor. So therefore from steam table we find out the temperature corresponding to this pressure 0.01701 bar. Then the value of temperature equal to 15 degrees Celsius. So this is the dew point temperature corresponding to the partial pressure of water vapor. So 15 degrees Celsius is the dew point temperature we got. Now relative humidity equal to phi equal to PV upon PS, where PV is a partial pressure of water vapor that we calculated. Now PS is the saturation pressure of vapor corresponding to dryable temperature. The value of dryable temperature is 30 degrees Celsius. So from steam table we write down saturation pressure corresponding to the dryable temperature. So PS equal to 0.04242 bar. So I write relative humidity phi is equal to PV upon PS, that is 0.01701 upon 0.04242. I got the value equal to 40%. Relative humidity 40%. Now next specific humidity W equal to formula is 0.622 into PV upon PV minus PV. So putting down the known values, I got humidity ratio equal to 10.914 gram per kg of dry air. The next is degree of saturation. So nu is equal to W upon Ws. We know the value of W. So we calculate Ws first. So Ws equal to 0.622 PS upon PV minus PS. So putting down the value, we got Ws 0.027944945. So I calculate degree of saturation equal to 39.1%. This formula is also available to calculate degree of saturation. That is PV upon PS into bracket PV minus PS upon PV minus PV. So I got the value of degree saturation, degree of saturation equal to 39.1%. Next, vapor density equal to, so rho V equal to W into bracket PV minus PV upon RA into TD. So I got the value of vapor density, putting down the value of, so RA is a gas constant, I call it, take it at 287. Then TD in Kelvin, table temperature in Kelvin. So I got density, vapor density equal to 0.01216 kilogram per meter cube of dry air. Next is enthalpy of mixture per kg of dry air. So enthalpy of mixture is equal to 1.022 TD plus W in bracket HFGdP plus 2.3 TDP. So HFG TDP, latent heat of vaporization of water at dew point temperature equal to 2466.1. So 2466.1 and dew point temperature is 15. So I got the value of enthalpy equal to 57.95 kilojoule per kg of dry air. So thank you for listening. Thank you.